Hi, my name is Harsh, and in this video, we are going to talk about the LocalStack VS Code extension. Last year, we released a preview of our LocalStack VS Code extension that allows users to deploy and invoke their local Lambda function directly from the Visual Studio Code environment. In this video, I'm going to show you how you can install and use the LocalStack VS Code extension alongside an AWS event-driven serverless architecture to show you how the extension allows you to have a blazing fast developer experience and faster feedback loop while you are building and testing out your local Lambda functions. So without much ado, let's get started. For this demonstration, I will be showcasing an event-driven recruiting agency application. This application deploys a bunch of SNS topics, DynamoDB table, SQS queues, Lambda functions, and S3 buckets. You might be able to notice that we have got three primary services over here. We have got the anti-corruption service that processes a change data capture event stream. And this particular stream is converted into events and transmitted to this particular SNS topic right over here. Second, we have got an analytics service, which has got an SQS FIFO queue that's linked to the SNS topic. And this practically serves as an event source for the Lambda function, which is storing all of the events in an S3 bucket. Lastly, we have got the SQS FIFO queue that's connected to the SNS FIFO topic, and it monitors various events such as jobs that are being created or jobs that are being deleted, and stores all of that data in a DynamoDB table with the help of SNS filter policy. All of these resources are deployed using Serverless Application Model, which is an infrastructure as a code framework that allows you to define your serverless resources in a standard template.yaml file, which can be further synthesized into CloudFormation templates, which can be further deployed on the AWS cloud. In this case, LocalStack has got SAM local, which is a wrapper script built on top of SAM CLI that allows you to create and deploy all of the resources on a running LocalStack Docker container. So without much ado, let's get started and let us first install the LocalStack VS Code extension. So I will navigate to the extensions tab in my Visual Studio Code, and I will search for LocalStack right over here. Maybe I should zoom this a bit. You might be able to see that we have got the LocalStack VS Code extension available in the extension marketplace. And once you can find the extension right over here, you can click on the install button to install the extension on your Visual Studio Code setup. Once the installation is complete, you are now all set to create and invoke your Lambda functions right on your local machine without having to manually execute some AWS CLI or some other commands. But before we do that, let us actually go ahead to our app.py file, which basically has all of the Lambda functions and all of the other resources that we basically want to manipulate and we basically want to work with. After the extension is installed, you might be able to notice that this particular file has got these two options on the code lens. One of them is deploy Lambda function, and the other one is invoke Lambda function. Now, with the help of deploy Lambda function, the LocalStack VS Code extension will be able to find the particular SAM template or the CloudFormation template that you want to deploy. And with the help of invoke Lambda function, LocalStack will query all of the local Lambda functions on your machine and will basically ask which Lambda function do you want to invoke. Now, since I want to first deploy all of my resources before I actually get to invoke them, I will click on deploy Lambda function, and it will straight up ask me to choose a deployment configuration. So in this case, I already have the template.yaml file. So I'll just click on that. And next, I will be asked to choose a unique name for my CloudFormation stack. So in this case, I will choose the name as LS demo. because I'm purely doing this for the demonstration purpose. And you might be able to notice that LocalStack has started to deploy my Lambda function. Now, this process, completely depending on your local setup, might take some time, because at the end, it's building the SAM application, it is synthesizing the CloudFormation template, and then it deploys the whole SAM stack on your local machine so that you actually get to invoke it. You will see this particular notification right over here that communicates that your Lambda function to LocalStack is now being deployed using ls-demo, which is the name that we had set beforehand. The interesting thing with LocalStack is the whole log experience, something that I very much love, because with the help of the log experience, you can practically see how your infrastructure as code stack interacts with LocalStack or the real AWS cloud service, and what sort of APIs it is basically hitting and invoking over here. So you will see like a bunch of CloudFormation API calls that are being made over here. And this can give us a very realistic sense if we are trying to develop, debug, or test our cloud applications right on our local machine. So I guess we should give this a few more seconds to ensure that everything is set up. And as we can see, now the Lambda function has been deployed to LocalStack. So we have got the notification right over here. So everything is now set up. And the next best thing that we can do is to actually go ahead and click on Invoke Lambda function. So in this case, you would be able to choose which Lambda function do you want to invoke. So we have got the AWS SAM CLI managed default. So that's not the one that we want to pick. We want to pick ls-demo because that's what we had chosen as a unique name for the CloudFormation stack. And now you will be presented all of the 3 Lambda functions that we have created on our local machine. Now, if you remember the architecture diagram that I was showing you before, you might notice that anti-corruption function Lambda is basically the entry point for the whole architecture. So I would click on this one, and this will start the whole invoke process. Now, if I go back to my terminal, and let's say maybe I just close all of this, you would be able to notice that the whole architecture was kickstarted in action. That's the whole beauty of event-driven architectures. And LocalStack basically spun up another Docker container that allows you to execute your Lambda function code within them. And then it started invoking a bunch of other AWS APIs. So you can see like SNS topics being published, Lambda functions being invoked, DynamoDB items being put, and things like that. Now, if you want to see like how this whole thing is panning out, you can actually go to the LocalStack Resource Browser, which is a pretty fascinating way of managing and visualizing the resources that are created by LocalStack on your local machine. So I can switch to my LocalStack dashboard. I can go ahead to status. It is showing me as offline, which is some sort of a mistake. So maybe I can just hit refresh. And you can see that I have got all of these resources like created, and I have all of these services running right on my local machine. So if I go ahead and click on something like, let's say, Lambda, you would be able to see that I have got the anti-corruption function, the analytics function, the inventory function available right within my LocalStack setup. You can also click on individual Lambda functions and you can see all of the details for them, which gives you a pretty nice idea about all of the resources that you have created. So this is the closest experience that you can get for a local version or a local AWS management console, because none of this data is actually being stored on any of our servers. Everything is connected to your running LocalStack Docker container. You can have the same kind of an experience with LocalStack Desktop if you prefer using these resource browsers just on your local machine, not use any sort of a web application with them. But moving back to, let's say, DynamoDB, because we saw some of the put item API calls being made. So I can click on the inventory table over here. And let us say that I navigate to the items over here, and you can already see that there are some data that is available in our DynamoDB table. So this is the whole event-driven architecture in action over here, and this is the whole sole purpose of the application. So that was all about how you can use the LocalStack VS Code extension. However, there are certain limitations that you should be aware of. First, the VS Code extension only supports deploying Python Lambda functions. Apart from this, you can only use SAM or CloudFormation templates while deploying your Lambda functions onto the LocalStack environment. Furthermore, the code length for invoke Lambda function is only supported if your Lambda function is present in the US East 1 region, and these functions are invoked with an empty payload. If you'd like to learn more about the VS Code extension, you can find the documentation for it right in the description below, alongside the link for our Slack community, which you can join if you have some feedback to share about the VS Code extension. I hope to see you in the future videos where we are going to talk further about how you can use LocalStack for a seamless Lambda development and testing experience. Peace.